obtuse angles and the unit circle. This is the unit circle. By that we mean it's a circle that has a radius of 1. So you'll see that it comes out to 1 and -1 on the number plane. This is quite useful for letting us understand sine, cos and tan of angles greater than 90 degrees. So let us have a look. We're going to start with just the top two quadrants, the first quadrant and the second quadrant. We'll get to the later quadrants in another lesson. Any point, for example, this point P on the unit circle, has the coordinates x, y, because we're on the number plane. And the angle is defined as the angle anti-clockwise around from our x-axis here, from the positive x-axis. So here is our angle. Here is our hypotenuse leading up to this point, which you can see is 1 because it's a radius of the circle. And quite obviously, in this triangle, this side here has the length that matches the y coordinate, and this side here has the length that is the x coordinate of where that point is. From that, you can see that we've got a triangle whose sides are x and y and 1 for the hypotenuse. Let's assume that this looks like about a 40-degree angle. I'm going to say this is our 40-degree angle here. Come back to that. The first thing we can do with the unit circle is get definitions for sine, cos and tan of the angle. So sine of the angle, as we know, is opposite over hypotenuse. If you look at the unit circle, here's our angle, theta. Opposite is y, hypotenuse is 1. Sine of the angle is y over 1. So sine of the angle for a unit circle has the value y. This is sine. Cos of the angle is adjacent over hypotenuse. Here our adjacent is x, hypotenuse is 1. So I've got x over 1, which is x. So cos theta is x, sine theta is y. And tan of the angle is opposite over adjacent. Our opposite is y, our adjacent is x. But we know, because we just worked it out, that y is sine theta and x is cos theta. So that gives us the rule that tan theta equals sine theta over cos theta. So these three identities are important. If we write those down as a rule, sine theta equals y, cos theta equals x, and tan theta equals sine theta over cos theta. Tan of the angle is sine of the angle divided by cos of the angle. Now, if we look at, as I said, this 40-degree triangle here, and if we used our calculator, which I've left here somewhere very sensible, here it is. So we're using the example of 40 degrees. Sine of 40 degrees is 0.643. Cos of 40 degrees cos 40 is 0.766. Tan of 40 degrees 0.839. If you have a look at these, especially mainly focusing on sine and cos, you can see that sine of 40 degrees will be our y, is about 0.6 on the y-axis. Cos of 40 degrees is our x, about 0.7 on the y-axis. It can be easier to look at something a little bit larger, like sine of 89 degrees. If that's the y, and we've got 89 degrees, we'd expect that to be very, very close to 1. Which it is. So you can see how these relate to our unit circle. What we're using this for is finding sine, cos and tan of angles greater than 90 degrees. Because so far we've only been working with right-angled triangles, and so we can only have an angle here of up to just under 90 degrees. What I'm going to do is draw a second angle coming out here to point Q. Drop this down. Here is our very pretty little thing here. What I've done here is I've mirrored that, so this is also 40 degrees. And so quite obviously, coming round here is 180 minus that 40 degrees. So this whole angle here is 140 degrees. Now you can see that I've got this angle of 140 degrees, and it is supplementary to this angle of 40 degrees. Have a look at this relationship here. This looks very much like it's going to be the same on the y-axis, that is sine. This relationship here looks like it's in the same spot on the x-axis, just over in the negatives. If you had a look at sine for this angle here, opposite over hypotenuse, this is still 1, this is still y, this is going to be the same. If you check sine of 140 degrees, which I'll write down here, 0.643. It's the same. And it makes sense that it's the same because I've got this angle here and it's coming to exactly the same spot on the y-axis. Cos of 140 degrees though, my x is over here in the negatives. Cos is adjacent over hypotenuse, but this x value is negative something over 1. I'm going to get a negative answer. Have a look at what happens when we do cos of 140 degrees. It's the same as cos of 40, but negative. And tan will be opposite, which is still positive, over adjacent, but I'm in the negative of the x. So positive divided by negative should also be a negative. Tan of 140 degrees is the same as tan 40, but negative. Now we just used 40 degrees and 140 as an example. What the rule is that we can see is that I can get sine, cos or tan for any obtuse angle, that is between 90 and 180, by its relationship to its supplement. So, notes to try to make that rule clear. For supplementary angles, the angle theta, such as 40 degrees, sorry about that there, and 180 degrees minus theta, such as 140, 180 minus 40 is 140, cos of the supplement equals negative cos of the acute angle. So cos of the obtuse angle can be gained by taking cos of the acute supplement and making it negative. Sine of the obtuse supplement is the same as sine of the acute angle. So sine 30 degrees and sine 150 degrees are the same. And tan of a supplement of the angle is the same as taking the acute angle, finding tan, making it negative. So the type of question we might be looking at there then, sine 35 is the same as sine of what obtuse angle? Now if you need to grab your calculator, there's no shame in that. If you want to do 180 minus 35, sine of 35 is the same as sine of 145 degrees. If you want to check it with your calculator, sine of 35, sine of 145, they're the same. Because they're supplementary and they'll come to the same point on the y-axis. Sorry, this is a long video. Cos of 10 degrees. Find the supplementary angle, 180 minus 10, 170. And that will be the same as taking cos of 170, but negative. Tan of 15 degrees. Take the supplementary angle, 180 minus 15 is 165, and we'll get the same result, but negative. If I've got an obtuse angle, 180 minus that angle would give me 60, and sine will be the same. Sine of 60 and sine of 120 will be the same, no negatives involved. Negative cos 130 will be the same as positive cos of its supplement, 180 minus 130, 50 degrees. Negative tan 150 degrees will be the same as positive tan of its supplement. The last thing we need on this, I'm sorry it's such a long video, is the exact values for 0 degrees and 90 degrees. We'll come to 30, 45 and 60 in the next video. Have a look at what would happen if you've got sine of 0 degrees. At 0 degrees, it's just a line straight across here. The hypotenuse is 1. Sine is opposite over hypotenuse. The opposite is 0. We've got 0 divided by 1, which is 0. Cos is adjacent over hypotenuse. The adjacent here, x, is 1. So since we know cos theta is x, x here is 1, this is 1. In the same way here, we know sine theta is y here is 0, we've got 0. And for 0 degrees, tan is sine theta divided by cos theta, 0 divided by 1, still 0. For 90 degrees, where am I here? That is here. Sine theta is y, we've got 1. Cos theta is x, we've got 0. And tan of the angle is sine divided by cos. 1 divided by 0, you cannot divide it by 0. Tan is undefined.